Welcome back to 3 Inquisitive Kids. In this video, we will be doing some problems about quadratic equations, and it's going to be a review on what we know about quadratic equations. The first thing I want to talk about is the roots of a quadratic equation. We have a quadratic equation which is ax squared in standard form plus bx plus c, and which equals 0. And the root of this equation, like if we factored it, would be x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So if we were factoring it, like the x plus and then x minus something equals 0, the x's values would be we can find it by using this equation. So that's called the root of the quadratic equation. And another thing I want to talk about is this thing inside the square root. This b squared minus 4ac is called the discriminant of the quadratic equation. And this is important, and we can't always use this to find how many solutions there are to the function or the equation. For example, if the b squared minus 4ac is greater than 0, then it means there's two different real solutions. If this discriminant is less than 0, then it means that there's no real solutions. Because if you think about it, if this is less than 0, then it would be negative. So it means we have a negative number inside a square root, and that would not make sense. And if this was equal to 0, then it means there's only one real solution to the quadratic equation. And if we take a look at what we mean on a visual graph, if the discriminant is greater than 0, it means there's two distinct real solutions. So one example could be this function. This and this are the two distinct real solutions of this y being 0. Essentially what we're doing is we're writing f of x is equal to ax squared plus bx plus c. But then we just turn this f of x part into 0 to make it into an equation. So then if f of x is equal to 0, it says there's two distinct real solutions. But if we have b squared minus 4ac is less than 0, we could have something like this. That's an example. As you can see, there is no solutions where we have y being 0. Now, what if we have b squared minus 4ac is equal to 0? Then it means we have one solution where the y is equal to 0. So that's what it looks like on a graph. Now let's go into our first problem. Here we have the function x squared minus ax plus 4 is equal to 0. And it has two identical real solutions. Find A. So let's first try to understand the question. It's asking for two identical real solutions. This means that there's two real solutions, but it says they're identical. This is the same thing as saying there's only one real solution. So what does it mean if a quadratic equation only has one real solution? Well, when we go back to the discriminant and we look at it, we see that if the discriminant, which is b squared minus 4ac, is equal to 0, then it means there's one real solution. In this case, what is b? b is negative a, so we have negative a squared, minus 4 times a, in this case the a is a 1, times c, which is 4 over here, is equal to 0. Now we have this, we can just solve for a. Negative a squared is the same thing as just a squared, minus 16 is equal to 0. This you can do a plus 4 times a minus 4, or you can move the 16 to the right, is equal to 0. So a is equal to positive negative 4. And that is our answer for the first problem. Pretty simple. Now let's take the difficulty notch up a little bit. And here, what about this problem? We have a quadratic equation, x squared minus 2mx minus 2m minus 4 is equal to 0. And in this case, the variable is x and m is a constant. And we want to prove this. No matter what m is, the function always has two distinct real number solutions. Our second problem says we have the equation x squared minus 2mx minus 2m minus 4 is equal to 0. And this is a equation about the variable x, which means that we can just look at m as a constant. We want to prove this statement. For all values of m, the function always has two distinct real solutions. We can use the discriminant to help us determine how many solutions a function has. A standard form of a quadratic equation looks something like this. Here, the a is this invisible 1. And then our b is the coefficient before x, negative 2m. And our c, because m is considered as a constant, these last two terms is our c. So now we can apply the discriminant. b squared minus 4ac. Because this function, we want to prove that it has two distinct solutions. This is not greater or equal to 0. It's just greater than 0. And then we can plug in our values. So b squared, which is 4m squared, minus 4 times a, which is a 1, times c, which is negative 2m, negative 4, is greater than 0. 4m squared plus 8m plus 16 is greater than 0. And then we can divide 4 on both sides. M squared plus 2m plus 4 is greater than 0. We can go ahead and factor this. This 4 can be split into 1 plus 3. So let's only use the 1. If we only use the 1, we get m plus 1 squared. And then this 3 we didn't use, so we have to add that on. Is greater than 0. We know that m plus 1 squared has to be positive, no matter what, which means that even if we don't have this plus 3, m plus 1 squared is still greater than 0. And then here we see that our discriminant, when we simplified it, it is indeed greater than 0 because a square has to be greater than 0. And it can't equal 0 because if it equaled 0, then 0 plus 3 would not be greater than 0. So this is true. Our answer is true. For all values of m, the function always has two distinct real solutions. Find the range of the function y equals x squared minus x plus 1 over 2x squared minus 2x plus 3. How can we solve this problem? Because we're looking for the range, we're looking for the set of values y can be, which means our final goal is to get to an inequality about the value of y, so about y. Our first step, we can start off by multiplying this bottom denominator on both sides. So we have 2yx squared minus 2yx plus 3y is equal to x squared minus x plus 1. And then we want to turn this into a quadratic equation that we are familiar with. So we can subtract the entire right side on both sides. So then the right, we would be left with 0. And on the left, we have 2y minus 1x squared. You see how I did the distributive property, factored it out? Plus a 1 minus 2y x plus a 3y minus 1. And this equals 0. And we can see that this, if we're applying this to the standard form of a quadratic equation, the 2y minus 1 is a, this is b, and this final section is c. Now we can use what we know about the discriminant, because if we're trying to find an inequality about y, the discriminant itself is an inequality, so we can use that to help us. In this case, we have b squared, which is 1 minus 2y squared, minus 4 times a times c is greater or equal to 0. And then we simplify. In the front, we have 4y squared minus 4y plus 1 minus 4. And then if we simplify here, we have 6y squared minus 5y plus 1 is greater or equal to 0. Continue simplifying. 4y squared minus 4y plus 1 is equal to minus 24y squared plus 20y minus 4 greater or equal to 0. Combine some like terms. Here we have negative 20y squared plus 16y minus 4 is greater or equal to 0. And if we want to, we can also divide negative 1 on both sides, but also switch or flip this inequality. Find the range of y equals x squared minus x plus 1 over 2x squared minus 2x plus 3. We're asked to find the range of y. This means we're trying to find the set of all values of y that y can be. When we're finding range or domain, it usually means we're trying to find an inequality about the variable. In this case, it's y. So how can we do this? Our first step is just to simplify our equation. So we can multiply the denominator on both sides. We get 2yx squared minus 2yx plus 3y is equal to x squared minus x plus 1. And then we can move all of these terms to the left side of the equation. We have 2y minus 1 x squared. I just factor out the x squared to combine the coefficients, plus 1 minus 2y x plus 3y minus 1 is equal to 0. We did that so we can clear one side of the equation to make it 0. And now we have something that looks familiar. It looks like a quadratic equation in standard form. Because now if we think about it, this is our coefficient of a, this part is b, and this last part is c. It's a constant because we don't have any x's in it. And then we can use the discriminant, because a discriminant itself is an inequality, and we're trying to find an inequality. So then b squared, which is 1 minus 2y squared, minus 4 times ac, 4ac, must be greater or equal to 0 in order for this quadratic to have a solution. So then we simplify. First, we have 4y squared minus 4y plus 1 minus 4 times, we can simplify these two parentheses. 6y squared minus 5y plus 1 is greater or equal to 0. 4y squared minus 4y plus 1, distribute the 4. Is greater or equal to 0. Then we can combine some like terms. Here we have the negative 20y squared. And I'm going to pause because look, we already have an inequality about y because y is in both a, b, and c. And we can ignore the x's we have because they don't matter anymore. We're just trying to simplify the discriminant. So let's continue. Plus 16y minus 3 is greater or equal to 0. Then we can go ahead and multiply negative 1 to both sides. 20y squared minus 16y plus 3 is, now we have to flip the sign, less or equal to 0. So then we could go ahead and simplify. When we simplify, we get 10y minus 3 times 2y minus 1 is less or equal to 0. So what does this mean? If we let this section be equal to 0, we would get 10y minus 3 equals 0. That means y is equal to 3 over 10. And if we let this section be equal to 0, it means 2y minus 1 is equal to 0. So then y is equal to 1/2. And if we look at this on the graph, we have a function that might look like something like this because it has two intersections with the x-axis. And look, here we have 310. Also, this inequality is currently about the y variable. So then y would be the horizontal axis and x would be the vertical axis. And y could also equal 1/2. So then, based on what we have right now, this entire section is the range for the values of y. We still have to go back and check. If we let y equal 1/2, and we brought it into this original quadratic, we would see that this first part, this first term, would equal 0. This term would also equal 0. And this last term will not even be true anymore. So it means that y cannot be 1/2. How do we represent that on this graph? Well, all we have to do is just hollow it out. So now it becomes something like this. And now our range for y, if we show it on the graph, would be from 310 inclusive to 1/2. So when we write that using our special notation for finding the range, it would be range of y is equal to square bracket 310, comma, 1/2, curly bracket. Okay, so we have the function y is equal to 6x, and you're trying to find a point on it where it's the closest to the origin, and you have to find what that distance is. When we come across these type of problems, first step is to draw it out on a graph. Here we have the coordinate plane. This is x and this is y. The y equals 6 over x graph function would look something like this. and it just keeps going on forever. So you're trying to find a point on here, any point, the closest point. Let me use a different color. That is closest to the origin. And I want to tell you that this type of function, y equals 6 over x, is a rational function, which means that it is symmetrical about the origin. So if we have this point that's closest to the origin, 0, 0, this point, if you make a straight line across, also has the exact same distance. We can call it d. And if we have it like this rings a bell. This d, we can think of it as the radius of a circle. So if we drew a circle about the origin and its radius was d, think about it. If this circle intersected, if only we look at quadrant 1, if this circle only intersects the function y is equal to 6 over x at one point, it means that d is the distance between the closest point and the origin. If we drew the circle a little bit too big, if we look in the first quadrant, it would intersect the function at 2 points. And if we drew the circle too small, there would be no solutions, no intersections. So how we can do this is you can write out a system of equations. One equation is y is equal to 6 over x. That tells us. Another equation is the equation of a circle. That is the radius squared, in this case d squared, is equal to x squared plus y squared, the two coordinates squared. We can turn this into d squared is equal to x squared plus 36 over x squared. We did this by turning this y into 6 over x. This looks a little bit confusing, so we can first let x squared equal a and d squared equal d, because now it can help us look at some terms as a whole. Now we rewrite what we have here using what we just defined. So d squared is equal to d, which is equal to a plus 36 over a. And then we can multiply a on both sides of the equation. So we have dA is equal to a squared plus 36. And then what we can do is put all of these terms to one side of the equation. We could get something like this. A squared minus dA plus 36 is equal to 0. Because if we do this, we have one side of the equation that is 0. And this looks very familiar. It looks like a quadratic equation that we're familiar with. If we do this, we can use our discriminant for a quadratic equation. So we have b squared minus 4ac is greater or equal to 0. This case, b squared is the same thing as d squared. Minus 4 times 1 times 36, which is equal to 0. So if we move this to the right, d squared is equal to 4 times 36. And then we can square both sides. So d is equal to, you can take this 36 and turn it into 4 times 9. So d would be 4 times the square root of 9, which is 3, which is 12. But we still have to go back to our original goal, which is to find what the lowercase d is. And up here we defined it. The uppercase d is equal to lowercase d squared. And we already know what uppercase d is, so lowercase d would just be the square root of 12, which is 2 times the square root of 3. And you might be saying, well, shouldn't it be positive and negative? Well, because we're talking about distance here, it has to be positive. So our only answer for d is 2 times the square root of 3. And that can be our distance for D. So that is our answer. I hope the problems we did in this video inspired you to solve problems with functions and quadratics at a whole different level, because you can use what you know about the basic concepts and switch them around and weave them together to be able to solve much harder problems. I hope you learned something from this video. I hope you enjoyed it, and I'll see you in the next one. Bye!